Okay, now I want to explain how the flow goes around a baseball in general, because this is going to be really important to this entire explanation. So again, I'll try to get that axis that I had before. It's tilted this way. The front end is closer to home plate than the back end, and now I'm risking blinding myself by having a laser pointer that's hitting the front of the ball. And the reason I want to do that is that if you imagine that that's the spot, that's the center of the ball where the air hits the ball as it moves forward. We call it the stagnation point in fluid dynamics. And so if you could, it's easy to imagine that all the flow that hits that point has to go wrap around the ball in all 180 degrees from there. So what I want to point out is what that spot looks like as the ball goes around. So if you can imagine the flow going around the ball from that point, you can see that in various configurations of the ball, it's having to, and in the various directions, it's having to cross seams. And if the flow goes across the seam, it's going to become turbulent in that spot. That's really the main point of this whole thing. Let me get that orientation a little bit better and try it again. See if I can get a whole rotation there. Um, uh, Obviously, it's going to be a little different if I change the angles a little bit. But one thing you should notice is that most of the time in most directions, the flow coming from that stagnation point in some direction is crossing a seam.